Hello again, pre-calculus. We are looking at lesson 5.6 today, and we are learning about the law of cosines. Previously, you looked at law of sines, and I have a handful of homeworks in at this point that I'm recording this, and they were looking pretty good, so I'm hopeful that it is going well. Nice part about law of sines, it used proportions. That's a pretty easy thing to mathematically solve. Today, we have law of cosines, which similar type idea in that given any combination or a combination of angles and sides in a non-right triangle, we can find missing angles and sides using the law of cosines. Now, first of all, as you are looking at your notes versus my notes, please take a moment. There's a little bit of information I've written down here, and there's an important typo. The law of cosines is typed wrong. So, in any triangle ABC, with angles A, B, and C, and opposite sides, lowercase a, b, and c respectively, the following equation is true. So the basic equation is a squared equals b squared plus c squared minus 2bc cosine of angle A. So do notice that that is a typo and it needs to be changed to cosine. Now, that's the equation that is written in your notes, but also notice it says this equation is true then for B and C as well. So I've written down the B and C equivalencies. B squared equals A squared plus C squared minus 2AC cosine B, and C squared equals A squared plus B squared minus 2AB cosine C. Now, as we look at this information, I want you to kind of look at the relationships. There's something that will be helpful to just be familiar with. But notice if you look back at the original, the side A squared, the one that starts A squared, also has the cosine of that corresponding angle. So the one that starts A squared has angle A. The one that starts B squared has angle B, and the one that starts C squared has angle C. Okay, so if you notice the next little part, some important information here. When solving the law of cosines, we are using the setups of side angle side and side side side. Okay, those are the two setups that work with law of cosines. Okay, when we did law of sines the other day, do you remember what setups we had there? We had several setups that involved two sides, and then also, well, several or just one. But we specifically worked with, I guess, angle, side, angle, and side, angle. So today we're specifically working with side, angle, side, and side, side. Now, couple of things. It says the key with solving law of cosine problems is to find the smallest angles first. That can be important in law of sines, but it's usually not. Usually law of sines kind of dictates the order. With law of cosines, this is important. You have to find the smallest angles first. If you start by finding a larger angle, it could make the difference and you could end up going the wrong direction. And then the other side note that I skipped over there right above this paragraph. Remember, basic triangle rule here. Two sides in a triangle must add to be bigger than the third side. And this is just the logic of triangles. Okay, if you're two smaller sides, I'm saying this wrong, hold on. Okay, yeah, if your two smaller sides do not add up to be larger than the third side, it cannot physically form a triangle. I mean, you could try and take those, certain side lengths and draw, and it just can't physically happen. So, a little bit about law of cosines. We're going to start first by solving a triangle that is side angle side. So looking at example 1, it asks us to solve triangle ABC, given that side A is 11, side B is 5, and angle C is 20 degrees. This means that we're looking for side C and angles A and B. Now, if it helps, you can draw yourself a picture here. And let's see, we know that I'm going to call this first angle C. We know that is 20 degrees. I'm going to go ahead and label the rest of this. B is a smaller side, A is a longer side, so I'm putting A on my larger angle. Side A is 11, side B is 5, and side C we don't know. So there's a visual if it helps. You'll notice that that shows this is a side angle side, because that's the information we're provided. Now, as you look at law of cosines, we are provided sides A and B and angle C. So first of all, if we are provided angle C, then that means we're going to have to use the equation that uses angle C. So we're going to be using the equation that starts C squared equals A squared plus B squared minus 2AB cosine C. Anytime you're picking which law of cosines to use, if you use the C squared equation, you're either solving for side C or angle C. Okay, same is true of the others. So I'm going to write out my equation here, and then we can fill it in. So C squared equals A squared plus B squared minus 2AB cosine of C. So let's fill it in. C squared stays C squared. I don't know what it is. 11 squared plus 5 squared minus 2 times 11 times 5 times cosine of 20 degrees. At this point, you technically could go ahead and put things in your calculator. If you put it in your calculator right now, type it as is would be an option. I'm going to take you through a little bit of the simplifying because we do need to pay attention to our order of operations here. 11 squared is 121. 5 squared is 25. 2 times 11 times 5. Well, 11 times 5 is 55. Times 2 is 110 cosine of 20 degrees. There's one more bit of simplifying I can do before I put this into my calculator, and that is the fact that I can add 121 and 25. 121 and 25 add up to be 146, and I still have minus 110 times the cosine of 20 degrees. You will notice I am not subtracting 146 and 110 because that 110 is attached to the cosine 20 degrees. At this point, you need to grab your calculator. Again, make sure your calculator is in degree mode. And you can just type that in as is, at least I can on my calculator, 146 minus 110 cosine 20. I'm already in degree mode from the other day. And my calculator is showing 42.633811171, as I hope yours is showing. And what is our last step to solving this? We currently have C squared. We need to know what C is. How do you get from C squared to C? And that is you take the square root. So I would encourage you to take the square root of the entire decimal that should still be on your calculator screen, not shorten it, just to make sure you are precise. My calculator reads 6.529457229. I'm going to give my answer with one decimal place. And so C is approximately 6.5. Okay. We have found C. Now, my recommendation, as you work to find other pieces, is that you try to avoid Actually, never mind, you can't do that. I always say try to avoid using the rounded pieces if you can. If you have to use them, you have to use them though. Okay, so we now need to find one of our angles. We can find angle A or angle B. If you look up at your equations, in order to find angle A, you have to have sides ABC. In order to find angle B, you have to have sides ABC. So in that respect, we're going to have all three sides. Now, angle A or angle B? Which one should I find first? And your answer should be the smaller one. Find the smallest angle first. And so in this case, is angle A or angle B going to be smaller? And we know that angle B is going to be smaller because it's across from the smaller side. So we're going to find angle B. And I'll be honest, in this case, if you found angle A first, I think you'd still... Oh wait, you might not be. I don't remember if you would be or not. So let's find our angle B. So I'm going to write down my equation so I have it in front of me. B squared equals A squared plus C squared minus 2AC cosine of B. And I'm going to start filling the information in. So B squared, 5 squared, equals A squared, which is 11 squared, plus C squared. I'm going to go ahead and use that 6.5 squared, minus 2 times 11 times 6.5, and then it's cosine of B. So we'll have to work with that in a moment. This is not one you can just automatically put into your calculator, but you can use the calculator to do some calculations. I'm going to go through and do some cleanup. 25 equals 121 plus 42.25 is what 6.5 squared is, minus 2 times 11 times 6.5 is 143 cosine of B. We'll go ahead and do another cleanup step there, and you can do your adding. So 25 equals, I can add 121 and 42.25, and I'm going to get 163.25 minus 143 cosine B. As you start thinking about how to solve for B, please remember you want to work to get B by itself. So I'm going to go ahead and take my 163.25 and subtract it over to the other side because I'm working to get that B term by itself. So if I take 25 and I subtract 163.25, I'm now going to be at negative 138.25. And on the other side, that equals negative 143 cosine B. Okay. Now, again, continue to work to get B by itself. So in this case, start by getting cosine B by itself, which means I'm going to divide the 143 to the other side. And I'm running out of room here. So if I divide the negative 143 to the other side, I'm going to have cosine B is equal to, now keep in mind a negative divided by a negative is a positive, and I'm not going to actually divide it yet. I'm just going to have cosine B is equal to 138.25 divided by 143. Okay, do you remember how, when it says cosine B equals, how do I solve for B? And the trick is, we're going to use that inverse function. So to get your B and your fraction to flip, we use the inverse function. So B is going to be the cosine inverse of that fraction, 138.25 over 143. So grab your calculators make sure that you know what you're doing here as you find angle B. So remember, cosine inverse is going to be using the second function of the cosine button, 138.25 divided by 143. My calculator says 14.8090775. I'm going to round that to one decimal place again. So this is 14.8 degrees. And now we have found angle B. Home stretch. We've got the easy part. And as we have the easy part, sorry, I am momentarily distracted. Easy part, how do we find angle A? If we know angles B and C, we can subtract from 180, right? So, please remember that angle A plus angle B plus angle C equals 180 degrees. We're trying to find angle A. Plus. So angle A plus 14.8 plus C, which is 20, equals 180. If you finish solving for angle A, you're doing 180 and subtracting the 148 and the 20 degrees, and you have 145.2 degrees. And that is your angle A. Okay, guys, that is your first example of law of cosines. Physically, there's a little bit more work to show than there was with law of sines, and I do expect to see some of this work shown. I understand that you may do some more pieces on the calculator, and some of these pieces may not physically be present on your paper, but I need to see appropriate work, so make sure you guys are showing that. Okay, now we're ready to spend some time looking at example 2, which are triangles that are involving side, side, side. So what happens when we have all three sides provided? So, example A, solve triangle ABC, given that side A is 7.7, side B is 4.5, and side C is 19.5. So, one thing I want to point out, and need you to remember, is that when you're dealing with given three sides, we talked about a key fact up here, and we always need to check that first before we proceed in this kind of problem. Remember, two sides must add to be bigger than the third side. So, do the two sides always add up to be bigger than the third side? And the key would be make sure the two smaller sides add to be bigger than the third side. Does that work here? So what you should be checking is to see what 7.7 plus 4.5 equal. So in order for this to work, in this particular one, A plus B has to be greater than C. 7.7 plus 4.5 has to be greater than 19.5. And 7.7 plus 4.5 is 12.2. Is 12.2 greater than 19.5? And it is not. So what does that mean? Can I take two sides of 7.7, 4.5 and draw a triangle that then has a third side of 19.5? And it's not physically possible. So this problem is essentially a no solution. It is not a triangle, and the reason is the two smaller sides must have a sum larger than the third side. So I'm going to write that information down here so you have it in writing. Two smaller sides must have a sum larger than the third side. Oops. So this is not a triangle. Okay, so beware of that as you're doing homework. Don't put a bunch of work into doing a problem that doesn't work. It could possibly happen if you start doing a problem and you get a mathematical error where your calculator doesn't want to agree with you, that this could be something that's happening. And it could just be you've made a mistake in your calculator, but just kind of beware. Okay, so moving along. Example B. Solve triangle ABC, given that A is 9, B is 7, and C is 5. Okay, what's the first thing I want to check? Do my two smaller sides add to be larger than the third side? So in this case, does 5 plus 7 add to be larger than 9? And good news is, here it does. Okay, so we're given three sides, so we are finding our three angles here. Which angle do I need to find first? If you recall from up above, it was always find the smallest angle first. And this is a problem where it would matter, again. So in order to find the smallest angle first, we look at the smallest side. Since C equals 5 is the smallest side, that's the angle we're going to start off finding. So we are going to be looking for angle C, which means I'm using the equation that is the C squared equation. So C squared equals A squared plus B squared minus 2AB cosine of angle C. This is going to be similar to finding angle B up on example 1. So fill in what you know. 5 squared equals 9 squared plus 7 squared minus 2 times 9 times 7 cosine of C, which is what we're trying to find. So I'm going to do some cleanup again. Some of this could be combined into the same steps or into less steps. Since I'm doing this virtual, I'm definitely going to show my steps. So if you're following them, you can hopefully follow them. So 25 equals 81 plus 49 minus 2 times 9 times 7, 126 cosine of C. If you have not already added 81 and 49, go ahead and do that. So 25 equals 81 plus 49. It's 130 minus 126 cosine of C. In order to continue solving for C, you want to get cosine of C by itself. So let's work to move the 130 first of all. So I'm going to subtract 130 over to the left. 25 minus 130 is negative 105 equals negative 126 cosine of C. Now to get that C by itself, you start by getting cosine C by itself. So if I want to get cosine C by itself, I'm going to divide the the negative 126. Negative 105 divided by negative 126, I'm going to leave as a fraction, except a negative divided by a negative is a positive, so I can go ahead and drop the negatives off. So cosine of C is equal to 105 over 126. And again, do you remember, how do we find C? We're going to use our inverse function. C is cosine inverse of 105 over 126. plug that into your calculator, and you will have angle C. Remember, it's the second function of the cosine button. And my calculator reads 33.55730.976, which if I round 1 decimal place, it is approximately 33.6 degrees. And we have one angle. Okay, what is the next angle we should find? And the next angle we should find is angle B. In other words, we want to save our possible obtuse angle for the last angle. So angle B means I'm going to use the B equation. So I'm going to write down my equation just to hopefully help you guys here. So B squared equals A squared plus C squared minus 2AC cosine of B. Fill in your information again. 7 squared equals 9 squared plus 5 squared minus 2 times 9 times 5 times cosine of B. Doing some cleanup. 49 equals 81 plus 25 minus 2 times 5 is 10 times 9 is 90 cosine B. I'm going to go ahead and add those two numbers if I have it. So 49 equals 81 plus 25 is 106 minus 90 cosine B. In order to work to get that B by itself, we need to first move the 106. So I'm going to subtract the 106 over to the other side. 49 minus 106 is negative 57 equals negative 90 cosine B. To get cosine B by itself, divide by the negative 90. So now I have cosine B is 57 divided by 90. To separate the cosine and the B, we use the inverse function. So B is cosine inverse of 57 over 90. And put it in the calculator. So cosine inverse, 57 divided by 90. My calculator says 50.70351976, which rounded to 1 decimal place is 50.7 degrees. And we've got 2 of our 3 answers. The last piece we need is angle A. How do we find angle A? All 3 angles in a triangle add up to be 180. So I know that angle A plus angle B plus angle C equal 180 degrees. How much work do I need to show, guys? Angle B and C are over there, so can I just jump and say that angle A is 95.7 degrees? Because I would be doing 180 minus the 33.6 degrees and the minus the 50.7 degrees. Okay, guys. That is some of the basics about law of cosines. Okay? Work through your examples and homework about law of cosines and see what you can do with those. Okay? As you get ready to flip to the second page. The second page uses law of cosines a little bit, but we also have some other different formulas to look at. So let's look at example 3. The bases on a baseball diamond are 90 feet apart, and the front edge of the pitcher's mound is 60.5 feet from the back corner of home plate. Find the distance from the center of the front edge of the pitcher's mound to the far corner of first base. So, we've got a baseball diamond here. I'm going to attempt to draw myself a baseball diamond here. Oof, that's a little lopsided. Let me try that one more time. That's a little lopsided too, but we're going to go with it. Okay, pitcher's mound is inside. Now, here's the thing. We don't exactly know where the pitcher's mound is, so I guess what I want you to understand, I don't know if that's exactly where I should have it, but it's not necessarily exactly on a line between first and third, okay? Depending on the field and on the regulations for that field. Okay, so the bases on a baseball diamond are 90 feet apart, so that means here the distance between home and first is 90 feet. And keep in mind, this is going to be my home plate right here. And my first base over here, because those are the two places they are referring to. The front edge of the pitcher's mound is 60.5 feet from the back corner of home plate. So this distance from here to here, okay, is 60.5 feet. Find the distance from the center of the front edge of the pitcher's mound to the far corner of first base. So that means we are looking for that distance right there. Okay. What did we form here? We formed a triangle, yes? And this is where I say the pitcher's mound is not necessarily on a line from first to third. Depends on where the pitcher's mound is located. And so you will notice I purposely tried to draw that pitcher's mound up forward a little bit, so I was not creating a right angle. Now, sorry, I'm looking at my picture in my notes. I may have just slightly misled there. Oh, I see what it is. Okay. I'm okay. We need an angle. Okay, in order for this to work, we need an angle. And if we're using law of cosines, remember it is a side angle side. So the angle we need to know is this angle right here at home plate. Now, keep in mind, at home plate, there's a 90-degree angle formed. If that line from pitcher's mound is coming straight down the center, that makes this half over here to be 45 degrees. And so that is the piece I almost overlooked. So now we have a side angle side situation on our hands. As you work to figure out law of cosines, it might be helpful if you want to go ahead and label your triangle ABC so you know how you want to plug it in. I'm going to do just that so we have something to reference. I'm going to call home plate A, pitcher's mound B, and first base C. That means side A is what I'm looking for. Side B is 90 feet. And side C is 60.5 feet. Since I'm looking for side A, we can use our equation. A squared equals B squared plus C squared minus 2BC cosine of A. From here, go ahead and fill in your equation. A squared equals 90 squared plus 60.5 squared I just realized I wrote degrees instead of squareds, didn't I? Whoops. It was 90 squared plus 60.5 squared minus 2 times 90 times 60.5 cosine of 45 degrees. Now, I'm sure some of you probably did this on the front side if you're using your calculators alongside of me, but could we just take our calculator and plug this all in right now? And we can. So I would encourage you to practice here. Grab your calculator. You've got your equation set up. Plug in 90 squared plus 60.5 squared minus 2 times 90 times 60.5 times cosine of 45. I plug that all into my calculator. I have a squared is 4,059.85715.3 is what my calculator says, but it's of that point where it's going on after that. What's our final step? We need to take the square root. So again, take the square root of what's on the calculator screen. And my answer rounds to be 67.3 feet. Okay, guys, so there is one application of law of cosines that you can use. Now, as we move along, example 4 and example 5 are two specific formulas that we can use here. Okay. On example 4, we're going to be using a new area of a triangle formula. Okay, so you'll notice in your notes, it says A equals 1/2 AB sine of C. Now, notice it says it's based on the side angle side setup. And I've also already written there that A right there stands for formula, area formula. That A is not saying angle A, it's saying the area formula. So, the idea here is that if it's angle C, it uses the other two sides, A and B. I've also written in the corresponding other formulas. The area could be 1/2 side A times C times sine of angle B, or area could be 1/2 sides B times C sine of angle A. Okay, so the idea is it's based on the side angle side setup, as I just said. Angle C would be the angle in between sides A and B. Okay, we're going to use this area formula on example 4. Find the area of a regular octagon inscribed in a circle of radius 9 inches. Okay, normally when I do this problem in class, my first task is to draw a picture. We're drawing a picture of an octagon inscribed in a circle. Well, my pictures are not usually that great on this problem, and now on top of it, I'm doing it on iPad. So we're going to go with whatever I can do here. I don't guarantee it's going to be great. I'm going to personally start, trying to remember where, I think I usually draw my octagon first. So it's a regular octagon, meaning all 8 sides are the same. I'm going to draw my octagon. So when I draw my octagon, I like to draw top and bottom sides, left and right sides. And then I like to draw the angles connecting them. Now you'll notice it says that my octagon is inscribed in a circle. Let me change colors here. Inscribed in a circle means that the circle is touching each of the vertices of the octagon, if you remember. So I'm going to attempt to make this the best I can. Whoops, I'm missing a point there. Okay, there is my red octagon inside my purplish circle. Okay, so we're asked to find the area. And the only information we have is that the radius is 9 inches. So, radius means from the center of the circle out to any point on the circle is 9 inches. So that dotted line right there I just drew is 9 inches long. That is the information we have to find the area of this entire circle. Okay. Do you see where to go from here? What you need to do is, if we draw in some more radiuses, so if I draw in, say, from the center to this vertex of the octagon, the center to this vertex of the octagon. Whoops. Center to the next vertex. Do you see what I'm drawing here? If I draw in a radius to every vertex of the octagon, I just created, you got it, 8 triangles. And so we're going to use these 8 triangles to find the area here. So, first of all, pick a triangle to focus on. I'm going to pick, I think, this triangle right here to focus on. I am tracing in green, if you guys can see that. What do we know about that triangle? We know 2 of the sides. 2 of those sides are radiuses. So 2 of those sides are 9 inches long. And what do we know about that angle in between those? So the idea here, let me draw this. We look at this triangle here. Oops. So we know it's 9 inches there, 9 inches there, and we need the angle in between them. So we need that angle right there. How do I find that angle? And the idea is, how many degrees in a circle? 360 degrees in a circle. How many triangles in this circle? 8. And 360 degrees in a circle divided into 8 triangles is going to be 45. So that means this angle right there is 45 degrees. And so now we have a triangle using the side angle side setup. So if we work this out, area is equal to, so using your formula up above, it's 1/2. And remember, it's the 2 sides times the angle in between them. So my sides are 9 and 9, so 1/2 times 9 times 9 times the sine of the angle in between them, which is 45 degrees. What's that going to find me? That's going to find me the area of 1 triangle. What do I really need? All 8. So after you find the area of 1 triangle, you can take that answer and multiply by 8. Grab your calculator and check it out. I'm going to put my 8 out front. 8 times 0.5 times 9 times 9 times sine of 45 degrees. Okay. And on my calculator, it's 229.1025971. In my notes, for whatever reason, I have a whole number here. So I'm going to say that's 229 square inches because it was area we were talking about, and my label was inches. So that is one formula you can use. This is an example where we have 8 of the same triangle, but you could use it with 1 triangle as well. And one last problem here, and that is another formula. Again, it's a very easy formula to use. The last formula for the area of a triangle was based on side angle side setup. As you look at this one, it's called Heron's formula. Given sides A, B, and C. So this is saying given all 3 sides. So this is based on a side, side, side. given A, B, and C are the number of sides of triangle ABC, and S, so S is defined as A plus B plus C all divided by 2. So when you see S in the formula, it's add all 3 sides up, divide by 2. And that's something called the semiperimeter. Then the area of the triangle is as follows. Area equals the square root of S times S minus A times S minus B times S minus C. It looks like a complicated formula, but it's really not. So let's look at our example here. Find the area of a triangle with sides 13, 15, and 18. So 13, 15, and 18 are going to be my ABCs. Honestly, it doesn't really matter which is which, but those are my ABCs. First thing you need to do before we actually use the area formula is let's find S. If you recall, it said S, or the semiperimeter, is A plus B plus C divided by 2. So that means in this problem, S is 13 plus 15 plus 18 divided by 2. Do the math there. 13 plus 15 plus 18, get that sum. Divide by 2, and S is 23. Okay, I'm not done. It asked me to find area, and that right there was just finding my semiperimeter. So area formula now. We're using this Heron's formula. Area is equal to the square root of S, which is what we just found, 23, times S minus A. 23 minus 13 times S minus B. 23 minus 15 and times S minus C. 23 minus 18. Okay, you could honestly plug that all into the calculator as is. If I do a little simplifying here, it's 23 times 10 times 8 times 5 under my square root, which actually gives me the square root of 9,200, I believe. Put that into your calculator. Square root of 9,200. My calculator says 95.91663047. If I go to the whole number for area like I did the last problem, this is approximately 96. It's area, but they didn't give me units, so we're going to say 96 units squared. That would be my generic label there. Okay, and that is Heron's formula. So hopefully you didn't find Heron's formula or this other area of a triangle too difficult. Just a different way to find area of a triangle. Okay, your homework that goes along with this is page 448. Numbers 2 through 28 evens, 31 and 32. For period 2, this is Monday, you should be listening to this video, and this assignment will be due on Wednesday for you. For period 5, this is Friday, you are officially supposed to be listening to this video, and your homework is due Monday. Period 5, if you watch this video before Friday, that's fine as well. Now, you'll notice down there at the bottom, I have team meetings scheduled, or meetings using the Microsoft Office Teams. These are times when we can get together as a class and I can answer some of your questions the closest to in person that I can answer. And so for period 2, that will be Monday at 1 o'clock that I will be having a Teams meeting. For period 5, that will be Friday at 9 o'clock in the morning, okay? And these are kind of set times based on when your period is and what the high school as a whole is doing. Now, Monday, when I do my meeting at 1 o'clock in the afternoon, that's officially for period 2. However, period 5 people, if you're available and you are interested in popping into that meeting, you are welcome to do so because it is just I just have one pre-calculus team set up in Microsoft Office Teams. On Friday, same thing is true. It's officially 9 o'clock in the morning, but if you're a member of Second Hour, you don't have anything going on, and you want to pop into the Friday meeting, you are welcome to do that, okay? So this would be a time you don't necessarily have to have listened to this lesson yet. It's probably helpful if you have, but if you haven't, I understand. And but we can look at questions from the past. Like I know there were some questions back on lesson 5.4, and we can look at some of those and just kind of touch base with everything that's been going on. The following week, we will be starting to look at some chapter review and starting to think about a chapter assessment coming up. So, good luck. I hope you're hanging with me here and working hard, and I will talk to you guys soon.